Greetings, everyone. Welcome to the Drobo Broadcast Network. My name is Mario Blandini at Drobo, and today's topic is SSDs, and specifically applying solid-state drive technology in a strategy that meets the needs of particular IT requirements in smaller organizations. SMBs meet SSDs. If you didn't think you could use them, we're here to tell you that it is possible, and they're efficient, light, and fast, just like the small business that you might be in. And joining us today is special guest Daryl Lang, who is SVP of Product Management over at OCZ Technology. How are you doing today, Daryl?
I'm doing great. Thanks, Mario. Appreciate you having us this morning.
Well, you're in studio, which is always special, a fellow Silicon Valley company here in San Jose, California. Solid-state storage is really transforming the storage architecture. It's just a lot different than traditional hard drives, and we'll talk about that during today's discussion. 15K SAS drives are probably what you've been traditionally using to get the I/O performance that you're looking for. So we're going to discuss the latest approaches and how you can do that. And we're really happy to have OCZ as a partner. We made a press release last month announcing that we're using OCZ technology in our Drobo B1200i. It's a company that was founded in 2002 and arguably one of the most noted vendors for flash storage in the industry. So as I let you introduce yourself a little bit, Daryl, I know that you've got a lot of press around your laptop drives, the new Vertex stuff. I personally want one for my MacBook as an internal drive, but OCZ does a little bit more than that. You also have a line of enterprise storage that goes into large-scale storage enclosures like a Drobo. So maybe you can tell us a little bit about what you're doing over there at OCZ.
Yeah, absolutely. Thank you very much. We're very excited to be partnered with Drobo. We're excited to offer our Talos-based SAS drive in the new Drobo chassis. And as you said, we do participate a lot in the laptop space. That's where OCZ historically came as a company. But a lot of the emphasis and the recent growth out of OCZ has been on the enterprise side with PCI Express and SAS-based drives.
And that's not unlike Drobo. We started off with photographers and videographers who needed a small, easy-to-use storage device. And as a special guest star, we also have Alex May in the house, Chief Marketing Officer, CMO over at OCZ. How do you do today, Alex?
Fantastic. Thrilled to be here.
All right, so it's been exciting as you guys are growing just from this laptop space into the enterprise space. Maybe tell us a little bit about what you do over there at OCZ.
Absolutely. I'm in charge of all the marketing, get to work hand in hand with Daryl to make sure that we get all the messaging right. And as we make this natural evolution, just like you have, really kind of from the client side up to the workstation enterprise side, we make sure we get it right.
Yeah, people say Drobos are cool, and it's true. We use a lot less power than the average storage device. We'll also talk about how SSDs are cool, not just low electrical consumption, but they do a lot of great stuff. Let's jump right into it. From a basics perspective, an SSD is not a disk. A lot of people say solid-state disk, which is a little bit of a misnomer. It is NAND flash on a circuit board. So maybe you could tell us a little bit, Daryl, about how they're different from hard disk drives, because the physics of magnetic media give you the properties of a hard drive. What makes an SSD different?
Sure. I think you touched on it at a high level. Basically, all of the SSDs that OCZ makes today use NAND flash memory chips, and we access multiple chips in parallel to achieve some spectacular performance levels. The more parallelism you can get out of NAND flash, the better the performance you can get. So we're a few orders of magnitude above and beyond the performance you can get, particularly on the small file random access patterns, which is really what is relevant in most enterprise environments.
Well, performance is the biggest differentiator, and I think a lot of folks, face it, most computer guys love the geeky stuff. They love to make it go faster, overclocking and wacky stuff like that. You mentioned random IOs or IOPS. Maybe you can demystify that word, input-output operations per second. It's thrown around in storage quite a bit. What should it mean to the average small business IT person?
Sure, really the way to think about it is how many transactions can I complete? And if that means you're running an Exchange server and you're 200 employee company, how quickly can your employees access their email records? Mm-hmm. Are they having a delay in the morning when everybody logs in at the same time? Maybe it's a virtualization, maybe it's a virtual desktop boot. Those are largely based on small file performance.
Yep.
Large file performance would be things like video editing servers, where you're streaming large, massive blocks of data.
Disk-based backup, too. Big data.
Absolutely. Great example. But for the traditional database workloads, those are very much small block, 4K, 8K, 16K record sizes, and they tend to be random access patterns.
Well, I think a lot of folks think of their storage infrastructure like traffic on a freeway. They're trying to optimize it for maximum throughput. How do you fit the most cars during rush hour? But Or what you're saying is rush hour may not be a freeway full of cars. It just may be that your latency response time is higher and therefore your applications aren't as fast.
Yeah, it's absolutely right. And if I follow your analogy, it's, I need to look at a passenger in every 8th car. That's kind of a hassle. If you want to pull all the cars off to the side of the road and try and line them up, that's nice, but realistically you can't do that. So.
Right, and most people would traditionally take 15K RPM SAS drives, and there's nothing wrong with them. They've been great for a number of years, but from a new technology perspective, there's an opportunity to take what used to be a lot of hard drives and replace that with a smaller number of SSDs to get the same benefit, if not better.
Yeah, I think we find a lot of customers had over-deployed SAS hard drives. They may have only needed a few petabytes of storage, but they might have deployed 10 petabytes just to get the performance level they needed.
Right.
So even though the unit cost may appear to be high on paper for the SSDs, at the end of the day, the big picture cost is actually quite competitive, and in fact, in many cases, may be more cost effective for the customer's needs.
Well, SSDs are faster than hard drives, and I think that it's fair to say there's no mechanical parts. It's coming from memory. So you talked about how they're going to feel snappier and more responsive because you have that fast access latency. Maybe you can talk a little bit about where they might be more similar, because if the data is sitting right underneath the head of a hard drive, that response is going to be pretty quick. Talk about the contrast between the performance that someone might expect in a real-world scenario.
Sure. As you said, if the data is in the right spot on the hard disk drive, or if we're talking about large block sequentials, hard drives actually perform that workload reasonably well. Mm-hmm. The question is, if the heads on the hard drive need to go seek data off one spot and then they need to move to another spot on the disk drive, what kind of a hit do you have there? And we tend to talk about that as seek time on hard drives. Mm-hmm. Well, given that, as you described, there's no moving parts on an SSD, really the question is how quickly can we go find data out of memory? And what you end up with is you can get IOPS in the tens or even hundreds of thousands of IOPS versus a few hundred on a traditional disk drive.
Indeed, and what we say at Drobo is you really want both. You want capacity and performance, and I like the idea that it's not something that is an or function, it's an and function. Hard drives have a certain role to play in the overall architecture, but certainly if you want your transactional stuff to go faster, an SSD helps out a lot there, so thanks for explaining that, Daryl. In terms of efficiency, this is another way to look at that performance equation. You can look at the left-hand side where you need a lot of physical spindles in order to provide the same throughput that you might get with one or a very small number of SSDs. That's a factor of that seek type thing, right?
Yeah, that's exactly right. The other factor is power, right? So if you deploy that 1,000 rotating drives versus, let's call it 100 SSDs, I think we could probably get the same performance with less, but just keep the math simple. The power savings alone over a cost period of a year or 2 years is going to make a big difference to an SMB. Maybe they're tight on that IT budget spend. Maybe they're tight on the OpEx cost. There is significant benefit there, addition to the performance as far as power, as far as cooling, and building up that data center infrastructure.
Well, I might be dating myself with this reference, but remember that Total cereal commercial where you could have 4 bowls of the bran flakes to get the same nutritional value as 1 bowl of Total? That's how I tend to see this, because in more real-world scenarios for an SMB, they might need to buy 2 chassis, one full of SAS drives to get the performance and one full of the SATA drives to get capacity. In a solution like a Drobo that mixes SSD with high-capacity drives, they can get both and have just one bowl to get all the stuff they need. So that's a great analogy there, Daryl. And in terms of the IOs per second, how should people generally think about that ratio? You mentioned kind of 10 to 1 in this case. 1,000 drives equals 100 SSDs. Is there a hard rule of thumb, like 10 to 1, or how do you normally consult with smaller organizations when they think about planning out how to use SSDs?
It's very workload dependent, but I think a general rule of thumb would be about 100 to 1. Mm-hmm. Obviously, our technical team is more than happy to get on the phone with any customers that need to walk through, hey, here's my workload, here's what I'm actually doing, here's my deployment, what kind of benefit can I see? Worst case, that's going to be about 10 to 1. Best case, that could be 100 to 1 or more.
Well, that wasn't a leading question, Daryl. I'm really happy you said it that way, because a lot of folks ask, hey, Drobo, why are you using only 2 or 3 SSDs? Why not fill the whole thing up with SSDs? Wouldn't it work better? And like a good hot sauce, a couple drops is all you need. You don't need to dump a whole lot on there because it really is highly potent and you get a lot of value out of that. So appreciate you breaking that down for us. In terms of why SMBs and SMB SAN, I haven't kicked anything over to you yet, Alex, so maybe this question will go for you. 15K SAS drives have a high cost and a low capacity, so you probably get folks wondering, can I get the same capacities, yet better performance with SSDs? And the answer is, it may not always have been the case in the earliest days, but at least here in 2012, it's certainly there, right?
Absolutely. One of the big things nowadays, the hot button really is virtualization, and it's really driving the need for more IOPS. And nothing does that better than SSDs. You really can take the advantage of the high availability with the live migration between servers without a SAN with a solution like this. And also with mixed workloads. They're really, really unpredictable. And something like the Talos, it really delivers unparalleled mixed workload performance across the board. So it's best to architect for the needs of the applications. And if you do that in advance, you're going to prevent a lot of phone calls, support requests. It's going to be a much more efficient and seamless solution from the get-go.
And I'm glad you brought that up about management, because we aim with all the things that we do at Drobo to make it as easy as possible. And I spent a decade plus in IT myself. I'm smart enough to deploy multiple tiers of storage, but do I know what application C, which is on VM5 on ESX Server 2, is going to be doing next week at 3 o'clock in the morning? I could try to be clairvoyant, but at the end of the day, it's going to be a guess at best. With SSDs deployed as a part of your tiered storage architecture, even for a small business, they can get this automatic acceleration, and that helps prevent the phone calls because they always point at the storage. I'm sure you've heard it a lot, Daryl. Something's going slow. Clearly, it's not the application. It must be the storage, right?
Absolutely. Well, we're here to help, and we can really solve a lot of those problems for the small business and the data center, so that IT manager doesn't get the phone call at 8 o'clock in the morning when all those users are trying to log in at the same time, and he says, go get a cup of coffee and come back. That's probably not the right answer.
Right. Let's talk a little bit about what the types of SSDs that are out there, because if folks go out, we love acronyms here in high tech, so there's MLC and SLC and EFD and all those sort of other things. A lot of what people may have been accustomed to, Daryl, traditionally have been the MLC drives because they're laptop oriented. And maybe you can describe just at the most basic level the difference between MLC and SLC and why it matters.
Sure. MLC is multi-level cell and SLC is single-level cell. The traditional thinking is that SLC is required in the enterprise and that MLC can only function in a laptop-type environment. And I think if you go back in time, that probably was a conservative approach and a safe approach and may have been the right approach. We've made a lot of progress over the last 5 years in improving the lifespan that we can get out of a drive as a whole, above and beyond the endurance that's just associated with the raw flash chips. We're building a solution. We're not just jamming a bunch of components in a box and shipping it out. And so what we find today is that many customers, even in the enterprise, typically have a 90-10 read-write workload, maybe an 80-20, and they don't really write that much data. They read a lot of data, in which case an MLC-based solution is going to save them money and meet their needs for a 3 or 5 year deployment. And the last thing we need our customers to do is overbuy and have the wrong experience with SSDs. Again, our technical team with the Drobo team can work together with the end customer to make sure that they're getting the right product. If what they need is SLC, we offer that, no problem at all. But generally, sorry, go ahead.
Yeah, Drobo has, as we'll show you later in the presentation, the ability to take different types of SSDs and put them into a Drobo with a IC dock adapter, just as an example. And so someone could take one of your SLC devices in a 2.5-inch form factor and put that into a Drobo just the same. So we'll talk a little bit about some of the design choices that Drobo made to offer the best combination of capacity and performance to customers in our B1200i. But let's talk a little bit about over-provisioning, because that's arguably what got us to where we are today. People over-provision their servers. They couldn't even barely scratch the surface on the memory and the CPU that's inside those. They're virtualizing now, doing a lot better. That mixed workload stuff that Alex talked about is causing the need for more high IOPS concentrated on a SAN storage device. But within the SSD itself, there is some over-provisioning. Talk about what that is and why it's important.
Sure. So over-provisioning makes a big difference in terms of the life of the SSD as well as the sustained performance of the SSD. And the reason for that is as flash cells get filled with data, before you can write new data, you need to clear out that old data. And when you write the new data, you need to write it in actually sequential chunks. So you have to reorganize your data. That's a process we call garbage collection before you can write new data. And the bigger the reserved area or scratch pad, or sometimes we call it over-provisioning space you have, the more efficiently you can do those functions. So you end up improving drive life because you're not having to move data more than once to get a large block of cells lined up. And you improve performance because running garbage collection real time is hindering your ability to write new, fresh data onto the drive.
Right. So that over-provisioning is related to endurance, or is endurance a factor of some sort of other design criteria?
Endurance has a lot of factors associated with it. Over-provisioning does factor into overall drive endurance, along with the firmware, along with the wear leveling, along with all the other bits and pieces that make up an SSD. It's a pretty complicated equation, and it's something that we've spent a lot of time and effort trying to improve.
Right. And in making that effort, you've combined the best of your technology approaches in your enterprise-grade SSDs. So if you go to OCZenterprise.com, you can find those specific products. We'll show you those here in a second. But you get both low and high capacities depending on what you want to choose. They have the highest level of over-provisioning and the highest endurance through that combination of factors that you talked about. And that's what really helps you use it in a RAID enclosure style environment. Drobo uses beyond RAID, a different technology, but similar approach. It's not a laptop drive that's being accessed a couple of times during the day. It's pounded on all day, every day by server applications. So it's really built to withstand the rigors of that environment. And so far, you can see these lasting 3 to 5 years, no problem, right?
Yeah, that's absolutely right. The enterprise drives are designed for a 24/7, 365 data center deployment. And 3 years, 5 years, not a problem at all. Again, it goes back to what's the key workload that the end customer is running, and did we spec in the right product for them in the beginning? I think the solution that we have with Drobo is a very, very good, robust solution for the SMB market. And are there corner cases that's not the right solution? Absolutely. Let's talk about those. If you don't have the right, or if you have a workload where this isn't the right solution, we can work together with the Drobo team and we can provide a solution for you.
Well, the way Drobo positions this, Daryl, is that if you're a smaller organization, 250 or fewer users, odds are you're running the same applications as a large organization. They're just on a smaller scale. And what they need is a mix of both capacity and performance in a fashion that's pretty much dead simple. Not that they're not smart enough to manage it, but rather, why would you want to spend your time doing that? No one's going to get spot bonuses for doing a great job on deploying that storage. It's all about the application uptime. So we try to make that as easy as possible. So enterprise SSDs are the ones that are designed for those applications, and why we use them here in our particular use case here with the combination of higher capacity hard drives to give you the best mix of both. So thanks for talking about that. Reliability, you talked about the factors that go into it. Naturally, people want a product that's more reliable, which is why they want to choose enterprise grade drives. They are built to thrive under those heavy workloads and ready to last a long time. You said 24/7 by 365, so a little bit better than 6 years time of service is what he mentioned. In terms of a practical deployment, you have SSDs that have a lot of different interfaces. I mean, you can have them as for embedded applications, but in your case, most folks are going to choose either a SAS or a SATA interface for their deployment because they're using it in the place of a hard drive, right?
Yeah, we have the hard disk drive, what we call hard disk drive replacement drives, as well as what we call a SAN replacement or a PCI Express card that could be added into the server or in the SAN. But I totally agree with what your statement was, which is the hard disk replacement is the thing that's easiest to understand, particularly in an SMB environment where you're coming from, you have experience with rotating media, whether it's 15K SAS, 10K SAS, or even 7200 SATA RPM drives that you're using for offline storage or going in users' laptops. So having something that looks and feels from a physical standpoint like a much faster hard disk drive is the simplest thing to deploy in an SMB.
And Alex, having been at OCZ for a long time, that's really how people first figured out how to use SSDs because it was very familiar to them. Have you seen that the adoption really pick up among small businesses?
Absolutely. I think, like you said, this is a product that you really can feel the difference in right away, whether it's a laptop you put it in. Unlike a lot of other products, you put this in and you can immediately feel the difference. Your system feels snappier. You know, the same thing translates to the SMB side as well, too. You don't have to wait long for your applications to load. It's just a much more efficient solution. And because it's something that you can plug it in and eliminate bottlenecks, it's something that is really being picked up on across the board.
Throw them into a Drobo. The second you put that third drive in, the SSD, we automatically enable the transactional tier, and you start to see a doubling of your I/O performance for transactional applications. How cool is that? It's the type of thing that people really do want to see that makes a difference. So let's talk about how you can leverage SSDs in an SMB SAN solution. I think folks are naturally concerned with the cost, and if they haven't checked prices in a while, they'd be surprised that it's getting a lot more affordable. And that's just a factor, Daryl, of not just supply and demand, but the fact that technology is advancing and you're able to produce these at a lower cost, right?
Yeah, absolutely. I think the market as a whole has been focused on cost, but OCZ is really a leader in getting cost out. We genuinely believe that cost is the number one bottleneck, or
the inhibitor.
Inhibitor, exactly. But from customers actually giving the SSDs a try. We talked a lot about how snappy they are, how fast they are. It's one of those things that once you try it, you're not going back. But getting over that first hurdle, give it a try. You will be quite pleased with the response time, with the results that you see, whether it's in your server, whether it's in your laptop.
Well, now in a SAN with Drobo, which is cool, and complexity is one of those things, that second bullet, Daryl, which a lot of smaller organizations have personally given us feedback on, because let's say they deployed SSDs. They'd probably put them as internal drives. That's an easy way to do it. But what about the applications you've already virtualized? There's no internal drive, so to speak. It lives in the SAN. So picking a place where to put these things can be a little bit complicated, which is really what drove our design of using the OCZ Talos SSDs as our reference architecture for our tiering there. And from a reliability and endurance standpoint, there are SSDs that are built for RAID enclosures, as you mentioned. We'll talk about that. But before we get into some of those specifics, maybe you can give us a little bit of information about some innovation that has been developed by the SSD industry, led by OCZ, around assurance of the storage and how you can make sure they're going to last you a long, long time, like you said before. Well, I'll talk a little bit about how data preservation in the case of power supply loss really is something they don't have to worry about anymore.
Sure. One of the things that we found when we first started going into the data center is that there's a big concern about drives losing power suddenly. And I actually had this conversation with a number of data center guys, and I said, well, look, don't you have a UPS on your server? And he says, of course we have a UPS on the server. The concern is that a hard disk drive fails, 1 out of 1,000, and I've got to go send a guy into that data center and pull it out and replace it. You'd be surprised how many times, instead of drive number 445, number 446 gets pulled out, which was an active, functional, good drive. So the question for OCZ was, how do we guarantee that any in-flight data that's being sent from the host down to that still good working drive is protected? So we have an array of discrete capacitors on the drive. So in the event of an emergency power loss, we have enough power that any in-flight data is written to flash, no possibility of data corruption or data lost once it's been received from the host to the drive.
Right, and Drobo makes it a little bit easier with our B1200i. The light is so in your face on which one to pull out. Hopefully it's a little bit easier there from an SMB perspective. And Drobo doesn't have any drive carriers either. This 3.5-inch OCZ Talos drive pops right in, smooth as ever. So that assurance stuff is cool. But how about wear leveling? This is the type of discussion, if I'm a small business, if I'm starting to have to understand it at this level, I'm thinking, hey, it's more trouble than it's worth. But it's really not that hard if you buy the right type of SSD that's designed to work in these environments, right?
Yeah, that's absolutely right. And I think your point is very valid. An SMB IT manager doesn't need to know what wear leveling is. What they need to know is that we do it well. And really, wear leveling is all about flash cells have a limited life in terms of the number of times you can write to the cells. So what we need to do is make sure that we're distributing those writes very evenly among all the cells so we don't get premature wear out of a small number of blocks. So we do that through firmware. There's a bullet on here talking about write amplification. So write amplification goes back to what I mentioned about garbage collection and block consolidation. And the more efficient you are with the way you write data to the flash determines a lot how long the drive will last. So under ideal conditions, excuse me, we can get write amplification well below 1, which means for every 1 byte of data that comes into the drive, only in this case we have a 0.3, only a third of that data is actually written to flash through dedupe and compression algorithms that can significantly benefit you from a performance standpoint as well as from a life standpoint on the drive.
So much cool stuff built in, but at the end of the day, it's a little black colored box. As long as the cool stuff's happening on the inside, the experience they get, though, they pop it in there. It's like a hard drive, just a whole lot faster.
Absolutely. It's our job to manage the details. They just need to drop it in, buy a Drobo box, and go to town. All
right. So there's a lot of them to choose from. And maybe, Alex, I'll ask you from a positioning standpoint. You even have a different website, OCZenterprise.com versus OCZtechnology.com. They're all NAND flash storage devices that are in a form factor. You can use like a hard drive, but maybe talk at the highest level about the difference between the product families.
Absolutely. So, like you said, we have two different websites, really one that caters towards the client side of the market and then one that caters towards the enterprise side of the market. Even though at the the very base level they use similar types of NAND, they're really designed and optimized for different applications. And we offer a complete spectrum of drives. For example, the Agility, Octane, these are really designed more for the client-grade applications, like you said, drop into a notebook, put into a gaming machine, a desktop. As you move up to the spectrum, something like we're putting in the Drobo device as a total solution, you're going to want to use an enterprise-level product. These are what the SMB guys are going to want. That's like a Talos or a Geneva drive, and these represent the highest performance, the highest endurance, really designed for enterprise workloads.
And Daryl, do these both come in 2.5 and 3.5, or are they just 3.5 or 2.5? Or do you get a choice of both sizes?
On the enterprise drives, we have both varieties, 2.5-inch and 3.5-inch. On the client-grade devices, we have everything from an MSATA device that goes in something like an Ultrabook to a 1.8-inch drive to 2.5 and 3.5, and a wide range of form factors.
All right. As a hardware guy myself, I know that can be tough as the product management guy carrying a zillion different SKUs and a zillion different sizes. The net, folks, though, is that you want to use an enterprise-grade drive in any storage enclosure type application to serve your server virtualization environment. Drobo is recommending and including Talos drives in our drive product configurations. So if you have a 2.5-inch drive, Daryl, there are adapters out there, and in the earliest of days, this is how people first tested your 2.5-inch drives, because 2.5 came before 3.5, didn't it?
Yeah, absolutely. We don't really need the real estate for a 3.5-inch form factor, and actually we've done some partnering with ICDoc as well, so we're quite familiar with their adapters, and mechanical fit is excellent on those adapters. But we found as a number of customers were still looking for 3.5-inch drives.
Yeah. Us included.
Absolutely. And so there's a few things that you can do in a 3.5-inch enclosure from a flash-based device. You can fit more flash chips, and in some cases that can actually help with cost, because flash pricing is not always flat. So we can sometimes save our customers money by deploying a 3.5-inch drive, which may be counterintuitive. There's physically a larger PCB, a larger housing, more components in there, but at the end of the day, if it saves the customers money and it fits their current chassis, it's a good solution, and we want to go to market with that product.
Great. And for folks out there that have their own enterprise-grade SSDs, if you want to put those into a Drobo, we're going to have a list of tested devices that are in our knowledge base, and we would recommend a product like this, all-metallic ICDoc type of adapter that would help you convert that 2.5 to a 3.5 so you can work in Drobo's carrierless design. We have no special tools, screws, drive carriers, so you want to be able to integrate that directly into the Drobo, and that's the way you could do it by converting that. And to get a little bit more into how the drives work in a Drobo Model B1200i, our strategy, as I mentioned before, is to put a couple drops of that hot sauce into the mix to really improve the overall service level over the entire solution across all of the volumes you have in a Drobo, and you just need a couple of those OCZ SSDs that I mentioned before. We do have automated data-aware tiering and a couple other recordings, demos, papers and such on our website that can describe a little bit more about how that works. But what makes it different is it really is ultra easy to use, 100% automatic. Pop in the OCZ Talos drives, and in a matter of instant moments, you are now getting that acceleration for your transactional performance. It's just different the way that people used to do it, Daryl, with the 15K SAS drives and having to figure out where I want my fast volumes, where I want my slow volumes. When's the last time someone asked you, if you asked them a question about trade-offs for a feature, where they said didn't say yes or both? They always want both, right?
It's always both, yeah, absolutely. And I think we think very highly of the tiering software that Drobo has brought to the market. It's one of those challenges where we don't believe hard drives are going away. And really the question is, how do we integrate an SSD with a hard drive and not make the end client do the work of managing which data goes where?
Yep.
And Drobo's brought that total solution to the market. We're very pleased to be partnered with the team here at Drobo.
Super. Well, in terms of putting it all together, not a lot of work for you to do. Our Drobo B1200i has support for SSDs, and specifically, when you add your OCZ Talos SSDs into the Drobo B1200i, we will automatically configure for you a transactional tier and both accelerate your transactional things and promote frequently accessed data so that you get that benefit across all the volumes. So you mentioned disk backup, Daryl. The same box here, they can use it for disk backup. If we get that data, we're going to put it straight to the bulk tier, the hard drives. No benefit of routing it through the SSDs. But all that small transactional stuff, 4K, 8K writes, or reads that are happening on a very frequent basis, the booting up of all those computers that you talked about. Yep. That's stuff that radically benefits from the SSDs. And in this case, you don't need a whole lot of it, right?
That's exactly right. Particularly in an SMB environment where you may not have the latest and greatest infrastructure through the rest of the data center. You know, in some ways, you might be overbuilding the SAN and bottlenecked somewhere else. So if you go, as much as we would love for you to deploy 100,000 SSDs, it probably doesn't meet the client's end needs. If you put in, I liked your analogy there for the hot sauce, 3 or 4 drops of that, and you're probably going to get 2 to 3x the performance from a real-world application performance, which is really what the traditional SMB is looking for today.
Fantastic. As we go here to wrap it up, some of the key takeaways. SSD, or solid state flash storage, it's transforming how you put storage together, folks. And likely you're listening to this broadcast because you have some interest in this area. We're not saying 15K SAS hard drives are bad, but traditionally they're the ones you used for I/O performance. It may be that those are the ones that don't really live on as long because SSDs can very well replace that particular use case. And the mixture of this stuff really helps make it really good. If you have any questions, feel free to put those in on the internet. I'll tee up a couple here while we have a couple seconds. Daryl, in terms of laptop drives, I think we hit that really hard. You don't want to put those into a RAID enclosure, but what role does firmware play in the SSDs? You talked about how wear leveling is done there. The firmware really does matter, but hopefully they can take it for granted, right? You guys just build it in there. Where does firmware play?
Firmware plays a huge role. Without firmware, you're basically talking about a car chassis with no engine and no transmission. Really, at the end of the day, it's all about the total solution. It's about the hardware and the firmware. But I've seen very good hardware with very poor firmware, and the drive's no good. On the opposite side of that, I've seen pretty mediocre hardware with exceptional firmware. You get a pretty nice solution at the end of the day. So I think firmware is almost, not quite, more important than the hardware as far as the SSD goes. But as I said at the beginning, it is the total solution that makes up the product.
We are a hardware company here at Drobo, but the vast majority of our engineering folks are firmware and software engineers that are writing the innovative code that makes the hardware do what it does. So again, at the end of the day, it is a total solution with that. Hey, as we wrap it up here, Alex, how can SMB folks, the clients out there, really benefit from SSDs? It's no longer just laptops only. They can really use this across their infrastructure to make things better across the board.
Yeah, this technology is ideal for this application. You get all the benefits of SSDs, like no moving parts, they're great endurance, obviously you have the performance and great latency, but just the fact that they're such a seamless solution now, that they require so little maintenance, that you plug them into a solution like the Drobo. It's fully automated. You get benefits of both worlds. You get the capacity as well as the performance. Less maintenance for the IT guys. So just an overall total solution that just works.
Well, with that, I want to thank you guys for coming in studio today. If you want to get additional information on the combination of Drobo and OCZ technology, you can go to our website under the How It Works section and data-aware tiering to get a full list of things, including a detailed white paper on exactly how it all works. If you want to learn more about OCZ, they've got a really cool report that comes out on a regular basis. You can follow on Twitter there. Alex, are you the guy personally doing that, or is that somebody on your team?
We have a team doing that, yeah.
All right, cool. So I know you guys are still a relatively small company. Wanted to see whether or not you guys are in that, but that's one cool way to interact with you guys. And above all, I want to thank everybody who has listened for their participation. And a big thank you to Daryl and Alex for coming in studio today for today's broadcast. Thanks again, guys.
Thank you, Mario. Appreciate the time.
It's our pleasure. Thanks so much.
All right, tune in next time as we bring you even more interesting topics from an SMB IT perspective. Mario Blandini here on behalf of Drobo and the Drobo Broadcast Network. See you next time.